Okay, class. Can I have your attention, please? Yeah. Now, there is a question, yeah, on this small. Are you ready? Yeah. Can I? Yeah. Now, this small, like a bit of bend down here. This is not. This does not mean the anchorage length. This means that to show to you that there's a bar stop there. Okay. If in the diagram we don't show anything, then you don't see the bar there. So it indicates something coming down. So actually there's a bar there. So this 100%, let's say 6 bar. So 6 bar will extend 0.15 L, and then 6 of them will stop there. And then 60%. 60%, which is, if you calculate 60%, if there are 6 bar, then 60% of 6 bar, you have 3.6 bar. So you cannot have 3.6 bar, so 4 bars, okay? 4 bars will extend further and then stop here, which is 0.25 L from the face of the support. So they show you another line here because the 6 bar that you design for the maximum moment at the support will stop here. Then 4 bars will continue further and then stop here. Then 20% of 6 bar, you get 1.2 bar. So you cannot have 1.2 bar. So you extend, this is minimum 1.2, you extend 2 bar. So 4 bar will stop here. Then the remaining 2 out of the 6, which is following 20% minimum. 20% is 1.2 bar. So we cannot have 1.2 bar. So you make it 2 bar. It will continue until the end here. Okay. Now, if in your design project you have a special beam very long, 6 meter, and then 2 meter, and then 3 meter, then you cannot use this. So in that case, I think we will have to look at case by case how do you consider your curtailment. This is for approximately equal span. Okay? Approximately equal span, one of the conditions. QK less than GK, and the load is continuous, okay? Uniformly, more or less uniform. Okay? Now, there are some calculation needed to determine the lap length and also anchorage length. So we do not expect you to go into that detail in your design project, but we want you to know that there are equations that we can use to calculate. Okay. Now for lapping, I think lapping class in your design project, you do not have to specifically consider lapping. So, but lapping, of course, in actual cases, mostly it will happen because, as I mentioned, the bar length cannot be, I think, satisfy the length that we want. That we have to use a bar of certain size and then lap them. But in your design project, we do not expect you to calculate, for example, how much is a lapping, okay? But just take note that in the design, actual lapping is necessary. And the lapping must follow, there are some lap length that we have to make sure that the stresses can transfer from one side to the other. So there are the requirement for lap length. Okay. Now, the next thing that class I would like to cover is loading on beam. Yeah. Now, loading on beam is referred to, it will depend on the beam that you are going to design. So by now, all of you have decided, I think, the beam that you have to design and follow the requirement. You must have continuous beam, and then those are the rules that you have to satisfy. And it refers to the key plan, where is your beam? Okay? So simply supported beam or continuous beam or H-beam or interior beam. So you have to refer to your key plan, because that is where you have to see where the loading comes from. Okay? Then the loading that we have to decide is decided span by span, because your span length might be different and your particular span might be supported slab on one side and other span might be supported slab on the other side, on both sides. So you have to determine span by span. Okay. Later I'm going to sketch a drawing indicating, because depending on the beam, your beam might support slab on both sides, and some of the beam, some span, there's only one side has slab, the other side void, there's no slab. So you have to look at your beam and then look at whether there are slabs, on both sides of the beam. So the beam supports slab from both sides or supports slab from one side only, and whether the slab is continuous, simply supported, is one-way slab or two-way slab. So the loading will be decided depending on is one-way slab or two-way slab. Then, if when you calculate beam loading, you have permanent load. Okay, permanent load, if it is given to you and indicated without self-weight, then the beam you have to consider the self-weight. Okay. Sometimes the permanent load is given to you by indicating this is without considering self-weight. So permanent load can come from finishers and other source. So if it is indicated without considering self-weight of the beam, then one of the permanent load that you need to consider is self-weight of the beam. Now, some of the resources that you refer to when calculate self-weight, it minus the thickness of the slab. Yeah, if your beam depth is 450, okay, then your slab thickness is 150. So sometimes we can take, when we calculate the beam self-weight, we can take away the depth of the slab. So in this case, you don't double consider, because the self-weight of the slab is already considered when we calculate load from the slab. So when we calculate dead load of the beam, we can take away the thickness of the slab, or you can consider again the whole depth of the beam. Okay. Because I think some of you refer to some notes where they will take away the thickness of the slab. Why they take away thickness of the slab? Because the slab self-weight is already considered when we calculate the permanent load from the slab. So when you calculate the self-weight of the beam, you can take away the thickness of the slab. But the difference is very, very, very marginal. So you can consider straight away the whole depth of the beam when you calculate self-weight. Okay? Now, if beam carries wall, yeah, especially if the beams carry wall, then you have to consider the line load from the wall, because the beam carries load from the slab and also carries load from the wall, if there is a wall sitting on the location where your beam is located. So those are the things that you need to consider. Now, I'm trying to use, because there are online, I cannot use the whiteboard, so I draw. Okay. Now, let's say you have to design this beam. Okay. Let's say you have to design this beam here, which is you consider as simply supported. Then it carries load from this slab. This is a two-way slab. So the load distribution is like this. And this is also two-way slab. If the ratio Lx, Ly, or Lx is more than 2, okay, is less than 2, then this is two-way slab. So the loading that you need to consider is trapezoidal shape like this. And this one, trapezoidal shape of the loading, you can analyze this kind of loading using the Excel program that I share with you. You can consider this kind of loading. Okay? If you design this beam, then the load from the slab only come from one side. Okay? And if we have, okay, if you have further if there is a situation like this is a special beam, not beam like this. This is a beam when the person drawing is hungry, then it becomes beam shape like this. So this is a void. This is a void. If this is a void, means if you need to design this beam, then the load from slab only come from one side. If there's a wall here, then you consider the wall load acting on the beam. So the wall load, if you can refer to some table giving you the wall load. The wall load sometimes they give in terms of certain thickness. It gives you in terms of how many kilonewton per meter square for certain thickness Then in order to get the wall load, you need to multiply the clear height, the height of the wall, then you get kilonewton per meter. The load on the beam always has to be in kilonewton per meter. So the slab load from slab is kilonewton per meter square. So you need to convert that into kilonewton per meter. Okay. And the load from the wall, if you refer, depending on the standard that you refer to, they give you sometimes for certain thickness, they gives you kilonewton per meter square, which means if you look at the wall, 1 meter square with that thickness is certain kilonewton. Then to get kilonewton per meter, you need to multiply with the height. You need to multiply with the clear height of the wall. Then you get kilonewton per meter. Okay. That is if the beam carries a brick. If the beam carry walls. If the beam does not carry wall, then the load only come from the slab and the self weight of the beam. Okay. Now, let me show you if the beam that you have to design, this is your column, the column. Now, to design this kind of shape of column is not in your syllabus. You design a rectangular column or square column, but to design this beautiful shape, artistic shape, I think is not in your syllabus. So I'm sorry, I cannot draw it in the proper way with the mouse here. I want to show you is that if you have to design this H-beam, second base almost done this key plan. So this beam here, if you have to design, so the loading come from, of course, this slab here, and also coming from this slab, and it also come from, maybe this slab is like this, okay? So those are the loading that it will goes to the beam, okay? So when H-beam, you have only loading coming from one side, Okay, this is a two-way. This is two-way slab. So the distributed loading is in this way. If it's one-way slab, then it's directly, I think, easy to calculate one-way slab. Okay. So in the next stage, I think, class, what you should be doing now is you finish your slab designing your beam. So you have to know the load acting on the slab that you have decided in terms of kilonewton per meter square. And then you need to know how the load is being distributed to the beam. Okay. So by looking at the load which is need to be carried by the beam, then you can model the beam. And use a program. This beam, you can model it. You model it, I think, in the Excel program that I share. Then you have to apply this loading. So that is the model that you are going to, that we need to use in order to get the bending moment and shear force. And you need to do, for continuous beam, you need to do the loading pattern. The loading pattern, max, min, max, min, max, min, you have to consider that loading pattern. Okay, the loading pattern that in order to get all the bending moment and then to get the envelope, and you decide what are the maximum bending moment that you need to design for the span at the support, and what are the maximum shear force at the support that you need to design for. So this can be analyzed using the software. I hope all of you have tried that. I think if there's any questions, any question using that you are not familiar with, how to model the loading, because there are instructions given to you how to model this loading. You have to model the loading correctly, then only you can get the shear force diagram and bending moment diagram.